Now we're ready to write our first microcontroller program. To start, we need to get into the user interface to enable us to write the program. Click on the Start menu, go to All Programs, click on Win AVR, and we're going to use the program called Programmer's Notepad. I like to maximize this window so I have the most space available, and we're going to change this from plain text to C++. So we have code highlighting and we have the proper syntax in the right color codes. The first line we're going to put in all of our programs is called the include statement for AVR io.h, which is a header file. .h files are called header files. The file that we're making right now is the .c file. The header file is added on to the beginning of the .c file that we're going to be creating. And it has a lot of code that we don't have to write that contain information and definitions for the AVR line of microcontrollers. Depending on the one we're using, it'll make those changes for us. Okay, so the first main routine we're going to be putting in, the main method. And this is the entry point into the program. This is really important to understand, that the main part of the program is where the actual execution starts. The void in the beginning means that we're going to not be returning anything from the main, and the void afterwards, which is in the parentheses, means that we're going to not have any information or variables passed into this subroutine. It is possible, and we'll get into it later, that we will be passing information into main, and we may be returning things from main, and those are much more complex and advanced concepts, so I'll wait until later to explain them. And we're going to create a block of code using the curly braces, and what this does is it allows you to contain a block of instructions, and it all pertains to the main subroutine. Okay, so the first thing we want to do is, since we have an LED that is connected to the pin 0 of port B, we want to make sure that port B is set for output, which means that we can output a voltage onto that pin. We don't want to set it as an input, which means it will be listening for a voltage on that pin. So let's start by using the DDR register. And when I say register, I mean that is a memory location that will affect either the state of the microcontroller or it'll create an action for the microcontroller. But all you're doing is you're assigning a number into a memory location. So the DDR is the data direction register, and it tells the microcontroller to either make a pin an input or an output. It's as simple as that. And then we're going to be working with port B, so the actual name would be DDRB. It's Data Direction Register for port B. And that's going to equal, we're going to do this, I'm going to show you many ways to do this, but we're going to start with a binary notation. This is one of about 3 or 4 ways you can set a pin to input or output. And to do this, we're going to start with 0B, and since there are 8, this is an 8-bit number, we're also working with 8 pins. We're going to use 8 digits. So I'm just going to write zeros in all the digits, which mean inputs for all the pins, and I'll change the pin that we're going to be working with after that. So let's do 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. And the pin 0 just happens to be the very last. It happens to be this particular digit here, because in binary numbers, this would be pin 0. This would be how you would start writing numbers. So we want to change that last digit. This is pin 0, and we're going to change it to output. So this is the binary notation that we're going to be using to change a particular pin to output, and in this case it's pin 0. If you wanted to change pin 1 to output, you would change that digit. And if you only wanted pin 1 to be output, then this is the way it would look. If you wanted to change pin 7, which is, this is 0 through 7, indexing from 0, we would change this to a 1. So that would mean that the output would be pin 7. Since we don't want that, we're going to go back to the pin 0 and assign output for pin 0. Now we want to apply either a 0 volts or a 5 volts to this pin. To light up the LED, and because in the circuit we applied the positive side of the LED to pin 1, we need to put 5 volts to that lead. So the way we do that is we have another register called port. We're going to be affecting port B, so we put a B after that. And that's going to equal, and we're going to use the same binary notation, which is 0B, and then we'll have 8 digits. That's 8 zeros. And since we want to put an output of 5 volts on pin 0, we're going to change this 0 to a 1. If I had a 0 there, then it's applying 0 volts. You'll also notice that I put in a semicolon at the end. This is also similar to the curly braces. It's a block of code. In this particular case, it's only one line or one statement of code. So we use a semicolon. If we have more than one statement, then we use curly braces, with each statement with a semicolon in this fashion that we're showing here. Now, I would like to also show how we make notes in our programming. And this is a really important concept to provide information into the program that won't be used in the running of the program, but will inform you how you wrote it and why you did certain things in the program. So we use the double /, and I'm just going to say in English what I'm doing here. So this is the data direction register and assigning pin 0 on port B to output. Okay, and I'll do the same thing for this line, assigning 5 volts to pin 0. This is the part of the program that we're assigning the pins, but we also need to have the microcontroller stay on. And in general, the main subroutine will contain an infinite loop within it. So the microcontroller stays on and it can keep running. So we're going to be using a while statement. While 1, and then we just use the curly braces. We're not going to put any code inside, we just want this to be a never-ending loop. And it'll also become very clear later on why we do this, and we'll be using this to our advantage. A lot of the things that we're going to be writing will be in this part of the program where we have the infinite loop, but we'll be listening for things to happen, and it'll react to things because the microcontroller will have what is called interrupts, and I'll get into that later. But right now we'll just keep it at the while 1. And now we need to save the program, but I'd like to create a new folder for this particular program, and it's good to put your projects in a folder. So I'm going to add a new folder on my desktop. I'm going to call it LED on. Now we want to save this file into that folder, and I'll search for it, LED on. Okay, so there's nothing in it, and we're going to name it main.c. And this is really important because the other parts of our program, or the make file that we're going to be changing in the next step, it will think your main program is called main.c, so we're going to just stick to that. We could change it in the make file, but that gets a little bit complex for the first program. Press save. Now you can see it changed the name, main.c, and every time you make changes you'll see a little star next to the name. Just press the save all button or the save button to make sure that that file is saved. Now we can't transfer the program yet, or we can't compile it and transfer the program yet into the microcontroller. We still have to change the make file. A make file it's a configuration that tells AVR Dude to go to the correct microcontroller, assign the right microcontroller, use the right programmer as we did in our test. So let's do that. Go to the start menu, go to all programs, and generally this is something you'll only have to do once when you make a new program. And we're going to use the program called mfile. So just click that, and here we're going to make some changes. We're going to make a couple changes through this menu system, but there's one change you'll need to make so it recognizes the programmer. The first thing we need to change is the microcontroller type, and I'm using an 18 mega and it's a 32. you need to select whatever microcontroller you're using. It also shows in a highlighted text what you've changed and where it's changed. Okay, so now we need to change the programmer. And the programmer is not shown on this menu. I'm just going to click on this and it's going to show me where it's located. I need to change that to the USB Tiny. So we have to go to the make file and we need to enable editing of make file. And all we need to do is change it manually. USB Tiny. And the last thing we need to change is the port. And it shows COM1, we're just going to use the USB port. Now we need to take this, we need to make sure that this file is saved in the new folder that we created. So we're going to save as, we'll search for that folder, LED on, and then we'll just click save. And the new make file should be into that folder. Now we're ready to program. Before we program, make sure that the programmer is plugged into the computer and the programmer is plugged into the interface that is plugged into the breadboard, as we did in our test. Okay, so let's go ahead and program. Go to Tools. We're going to first make all, and hopefully it'll be okay. I saw something there that didn't look right. Let's see. Generally, if it shows an error or a warning, it'll show in this color. And it's telling us that we should make the return of main an int, but it's only a warning, so I'm going to disregard that and see if it still works. Alright, so let's try to program it, and hopefully we won't get any errors. Looks like it worked. And let's check out the results. Okay, the chip was just programmed. We just pressed enter, and you can see that the LED is on. The LED was plugged into the number 0 pin for port B, and we're applying 5 volts to the LED, so we do get an on state. Okay, so we've looked at the circuit and we know that the LED is on. Everything with this program will be a lot easier now. We did a lot of steps that we really don't need to do over and over again, like creating the make file. Right now we can essentially modify our program, and all we'll have to do is go to Tools, Make All, and then Tools again and Program, and those changes will be made automatically, and it will successfully program it as long as we have no errors in the code. So we have successfully created our first program. We know that the microcontroller is working, and we are able to program the microcontroller, and you've learned how to change the data direction for the pins on the microcontroller. We know how to control the output, and next we'll probably add a little bit more creativity with this LED. Maybe we'll make it blink. Thank you very much.